Welcome back to another Cyber Apocalypse CTF 2022 write-up video. In this video, we'll be covering the Forensics Challenge automation. Let's get into it. So, when you download the file they provide, you get a PCAP file, so let's just crack that open. Okay, let's go to Statistics and Protocol Hierarchy, and right off the bat, it looks like we have some HTTP data with a media and data, so let's go ahead and apply HTTP as a filter, close. And if we come through here, we see an interesting entry here that says desktop.png. That looks kind of weird, doesn't it? So let's just follow the HTTP stream on that. And that's not a PNG, that's base64. Can you see where this is going again? Just like the other two challenges, this one is probably malware related. And it's just hidden in an unsuspecting file that's called a .png. It's not actually a .png. So let's just copy this out to CyberChef and see what it gives us. So let's do from base64. There we go. Oh, look, another malware script. All right, let's copy that and go to PowerShell and see what we're dealing with. Let's go ahead and save it this time so I don't forget. Let's just call it auto. Should be fine. Okay. So if we take a look here, this is looking kind of messy here. So let's clean this up a little bit just so we can make it more readable. It's already looking better. There we go. Yes. Okay. So what it's doing is, because this is the main execution right here, these are all functions up here, so those are only getting executed based on what's down here. Filter parts, okay, I don't really feel like going through that. There's a key, and then it's resolving DNS name -txt, and then for each output, after it resolves that DNS, it's taking strings and it's decrypting the strings, and then it looks like it's re-encrypting the strings, and then it's doing more DNS resolving, and it's appending that domain of whatever that encrypted string is, I guess. Well, actually, it makes a pointer variable here. Yeah, let's go ahead and put that on a new line as well. All right, so it's taking that encrypted string, that $PR, and then it's appending it to the domain and trying to do a request with it. Okay, so I kind of get the gist of what's going on. Let's see what decrypt string and encrypt string do. It's AES. Okay. All right. And it gives us the key here. But AES also involves an initialization vector, which appear to be the first 16 bytes of whatever it's looking at, I guess. I wonder if we'll find that out soon, huh? Okay, so now that we know what the script kind of does, let's go look at DNS, shall we? So it looks like what we can do is take this TXT record here and then just decrypt it, and maybe it'll give us something nice and readable, huh? All right, so let's close that. So let's sort by DNS. And we're looking for a text record, so here's one right here and here. So let's just follow UDP stream. Yes, that looks like some base64. And if we come back to the script, it looks like it's converting some bytes from base64 inside decrypt string. So it looks like whatever that base64 string is the encrypted string with the initialization vector. So this is probably what we want. Now, it looks like there's a bunch of null crap following it. So we can probably use T-Shark to kind of filter all that out. So I'm going to try to attempt to grab this record with T-Shark. The way I can do that is, well, we can just select it, and then we can click this, and then answers, and then we can see kind of, I need to pull up the hex. There we go. Yeah, so each of those text values is one of our base64 strings. So if we just right click and apply as filter selected, oh, that's not exactly what I was going for. Here we go. Let's apply this as a filter instead. So we're looking for, well, we want to filter by dns.txt, but we want to filter where dns.txt is not empty, because we could get a lot of extra stuff if we don't filter by that. So I already have PowerShell open here, and I believe I already had the tshark command right here. So all this is saying is grab the fields of dns.txt, and we want dns.txt where the actual text entry is not empty. So if we click enter there, it gives us a nice comma-separated list here we can use to our advantage. But let's go ahead, and since we need to convert all those to strings, we can easily do that in Notepad++. So let's do a Control H, and we want to replace the commas with quote, comma, quote. Replace all. All right. And then we just need to add a beginning quote and an ending quote. And that should be a nice little array we can loop through. So let's come back here. Let's see which parts we don't need. We don't need this onward, probably. Now let's make a little array. So we'll do $array equals, well, let's call it encrypted, because it is the encrypted portion. At, and then we can just paste all those in. Boom. All right. And I need an equal sign because it's a variable assignment. All right, so then we're just gonna do for $E in $encrypt. And I think I need to do for each. There we go. What we're gonna do is we're just gonna do the decrypt string right here. All right, in theory, this should work. Okay, we've got some problems here. Interesting. I think what the issue is we're trying to pass in this key here. And if you look up here, it's never actually converting our key from base 64. So we probably need to convert it from base 64 first in order to get what we want out of it. So I'm not sure how this even worked without doing this, but anyways, we can do that simply by just using what's already available inside the decrypt string function. So now let's give it a whirl. And it is still bugging because I need to do $E. My fault. All right, now it should work. There we go. All right, so now we have another base 64 string right here that we can probably decrypt easily. So let's just do system.convert from base 64 string. And then we need to, of course, do a little character conversion here. Char. Here we go. And then join. And then there's the first part of our flag right there. HEB, you can. All right. So unfortunately, there's a part 2. Well, let's go back to the Wireshark file. And let's go ahead and filter by DNS. We know that the script was sending queries such as these right here, where they append parts of encrypted data to the domain. So I wonder if we can take those encrypted pieces of data and decode them, because the packets may have been modified or whatever, so that these are not what was decoded and re-encrypted for the first part of the flag, if that makes sense. So let's go ahead and grab that data. I have the tshark command already prepared for it, because all we're looking for is, they're all the same length. I believe they're 16 bytes each for the header. So we're just looking for a frame length of 115, which is the condition I have here, and we want the DNS query name. So that's what this value is right here. In fact, I can expand, I believe, there. See, this is the DNS query name. So if we were to apply that as a filter, hold up, we need to apply this part, sorry. You can see it up here. So, that being said, I actually have it printing out to a data file, but let's go ahead and just run it without that so I can see it. Okay, cool. So let's just go ahead and copy all that over here. Just make a new one, boom. And what we're gonna do is we're just gonna remove the .windows.liveupdater.com. And then we also probably, I don't know if this matters, but we probably want to remove the new lines. So there we go. Now we know that the first 16 bytes of this are the initialization vector. So keep that in mind. Now, when I tried solving this challenge originally, I actually tried to do this in here, and I'm sure there's a way you can do, like, reverse this to do it in here, but it wasn't working for me. So then I just broke it down, right? It's AES. We had the initialization vector and we have the key. So what's stopping me from just decoding this in CyberChef? So let's bring that over here and let's do Control V and let's drag that in there. And now we do want to do from hex. So let's do that. And then let's do AES, decrypt. Okay. Now remember, we want these first 16 bytes. So I believe that's up to the 36 here. Yeah, because remember, every byte is represented by 2 characters in hex. So we'll just cut that out and we'll paste that as the initialization vector and keep it as hex. And then we need the key, which we have in here as well, right here. So we'll copy that. Paste that in here. Now we need to change that to base 64. Oh, I didn't need the from hex. Oh, my fault. Because it has a value. It has a. I just noticed this. I'm sorry. This AES decryption function in CyberChef already has a option to have the input read in as hex. So I didn't need that. But you can actually see some plain text here, and you actually see the second part of the flag right here. Automate, but you can't hide. So the whole flag is HTTP, you can automate, but you can't hide. So let's go ahead and copy that out to our submission box here. So there's the first part, and there's the second part. And there we go. If you enjoyed the video, drop a like and subscribe to the channel to show your support. Turn on post notifications to get regular injections of cyber content directly into your feed. Check out our Patreon, join our Discord, and follow us on Twitter. Links in the description box down below. And leave any feedback or questions in the comment section down below. This is Almond Milk. Thanks for watching. Goodbye, world.